Hi, welcome to my channel. In this video, we want to solve the following problem. In right triangle ABC, angle BAC equals theta, angle ACB equals 90 degrees, BC equals A, AC equals B, and AB equals C. Given that C squared equals DE, show that theta equals arctangent A over B plus D plus arctangent A over B plus E. And now for the solution. By Pythagoras theorem, AB squared equals BC squared plus AC squared. So C squared equals A squared plus B squared. Next, extend CA beyond A to P such that AP equals D. Let angle BPC equals alpha and angle ABP equals beta. Since angle BAC is an exterior angle of triangle ABP, by the exterior angle theorem, we have theta equals alpha plus beta. Next, consider triangle BPC. CP equals B plus D. Since the triangle is right angled, tangent alpha equals BC over CP, which equals A over B plus D. Therefore, alpha equals arctangent A over B plus D. Next, let us calculate BP. By Pythagoras theorem, BP squared equals BC squared plus CP squared, or BP squared equals A squared plus B plus D whole square. Expanding gives BP squared equals A squared plus B squared plus 2BD plus D squared. Substituting C squared equals A squared plus B squared, we get BP squared equals C squared plus 2BD plus D squared. Therefore, BP equals square root C squared plus 2BD plus D squared. Next, drop AQ perpendicular to BP with Q on BP. Now, consider triangle AQP and triangle BCP. We claim that triangle AQP is similar to triangle BCP. Since angle AQP equals angle BCP equals 90 degrees, and angle P is common, the two triangles are similar by AA. Since corresponding sides in similar triangles are proportional, we have AQ over BC equals AP over BP. So AQ over A equals D over square root C squared plus 2BD plus D squared. Therefore, AQ equals AD over square root C squared plus 2BD plus D squared. Next, consider right triangle ABQ. Let us calculate BQ. By Pythagoras theorem, BQ squared plus AQ squared equals AB squared, or BQ squared plus AD over square root C squared plus 2BD plus D squared whole square equals C squared. After expanding the brackets and isolating BQ squared, we combine the terms in the right hand side to obtain BQ squared equals C to the power of 4 plus 2BC squared D plus C squared D squared minus A squared D squared over C squared plus 2BD plus D squared. We simplify C squared D squared minus A squared D squared using C squared equals A squared plus B squared to get BQ squared equals C to the power of 4 plus 2BC squared D plus B squared D squared over C squared plus 2BD plus D squared. Next, we substitute C squared equals DE in the numerator to obtain BQ squared equals D squared E squared plus 2BD squared E plus B squared D squared over C squared plus 2BD plus D squared. After factoring D squared in the numerator, we obtain BQ squared equals D squared times E squared plus 2BE plus B squared over C squared plus 2BD plus D squared. We recognize the term in the brackets as b plus e whole square. After taking the square root, we finally arrive at bq equals d times b plus e over square root c square plus 2bd plus d square. Finally, let us return to triangle ABQ. In right triangle ABQ, tangent beta equals AQ over BQ, or tangent beta equals AD over square root C square plus 2BD plus D square divided by D times B plus E over square root C square plus 2BD plus D square. D cancels, and square root C square plus 2BD plus D square also cancels, giving tangent beta equals A over B plus E. Thus, beta equals arctangent A over B plus E. Since theta equals alpha plus beta and alpha equals arctangent A over B plus D, we have theta equals arctangent A over B plus D plus arctangent A over B plus E, which completes the proof. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.